we'll look at the models of that, and then we talk about the volumes and capacity. So that'll be the first part of the lab that we do this week. And then the second part is we're going to look at models for the urinary test. So it's two-part, and then next week is your lab test already, which also includes the vessels that we did. So this week, renal and respiratory lab, and then next week is your S2 lab. Boom. All right, so let's go ahead and get an introduction into the renal system. Esmeralda, could you hit the light for me, please? So here's our kidneys. Very basic outline of the renal. Thank you. Renal is the kidneys. So we have two kidneys. We have ureters coming down. They drain into the bladder, and then that goes out the urethra. So that's the most basic part of the renal system. On top of the kidneys, we have our suprarenal glands, also called the adrenal glands up there. Those are the ones that are going to secrete cortisol when we get under stress, and they also secrete epinephrine. So right there on top of the kidneys, so they're called suprarenal. Looking at our vessels, we have the big fat aorta coming down, so that's our abdominal aorta, and then we're splitting off the common iliacs, external and internal iliacs. And then are returning the blood back up, external iliacs, common iliac, inferior vena cava. And then branching off of that, we're going to have our renal arteries and veins, and then our suprarenal arteries and veins. So remember, that's our celiac trunk. This one's going over to the liver. This one's going over to this way. So that's the basic anatomy of the renal system. Yes.
Are there only, do we only have two ureters?
Yes.
Because we used to have patients that would come back from surgery and they would have to get a next ureter, and it seemed to happen all the time, so I thought there was like
Oh, no, one for each kidney going down. That's not a good thing, a mixed kidney, or a mixed ureter. Okay, so let's talk a little bit about the renal system. Its main function is that it's going to filter for us. So lots of blood is going to come into the kidneys through the aorta under high pressure, and it's going to force all the blood in, and then we're going to start filtering. That's the main job of the kidneys. So we're going to filter 200 liters of fluid from the body daily. And what we're doing is we're allowing toxins, metabolic waste, and excess ions to pass out via the urine. We actually only excrete 1% of what we filter. Everything else, 1 to 2%. 98% gets returned back to our body. But the kidneys are filtering it, reclaiming what we need, water, and then the ions, and then we're going to get rid of the things that we don't need, like our toxins and our waste. Uric acid is a byproduct, so we're going to push things out via urine. We're going to return 98% of the stuff back into the blood because we need to reclaim that. And the kidneys are our major excretory organ. So we know they're going to filter, we know they're going to excrete, but they're going to regulate blood volumes. This was question 23, 4, and 5 on the test that you haven't had yet. So they're going to regulate blood volume, and by filtering it, we're purifying the blood, but we have to return it back to the system. It's a closed loop system, so we have to keep everything returning back. And when we maintain volumes, we maintain pressure. So we need to keep regulating our volumes. We can pee fluids off if we have too much volume, or we can hold on to it if we don't have enough volume. And then that's that whole chemistry behind ADH, antidiuretic hormones, that's hold on to. And that's also that whole chemistry behind renin, makes angiotensin 2, makes aldosterone and ADH. That was the second question that you get credit for. So we're regulating the chemistry of our blood. We also have to balance salts and water, because wherever sodium goes, water goes. And if we're monitoring our sodium levels, then we're automatically monitoring our water levels. And if volumes are in homeostasis, pressures in homeostasis. If volumes are up because we have too much sodium, wherever sodium goes, water goes. And volumes go up, and blood pressure goes up. If volumes go down, we're peeing off too much, wherever sodium goes, water goes, we're getting rid of volumes, then blood pressure comes down, or gets too low. So we don't want that to happen. So one of the main ways we're going to alter that is by salt and water. So we got a lot of chemistry going on to regulate volumes, which is ADH, and then that whole renin, angiotensin 1 and 2, aldosterone situation. So a lot of chemistry going on. We're going to balance acids and bases. This is that whole equation we looked at with the respiratory system. CO2 is over here, bicarbonate is over here. So now we're into the renal system, and how the kidneys regulate is with bicarbonate, HCO3. And we're going to push it back into the middle towards carbonic acid, or we're going to push it that way. So with CO2, we know we can speed up respiration or slow it down, blow off CO2 or hold on to CO2, and then we're pushing it towards the middle or going away from that reaction. Same thing with the kidneys. Now we're on the other side, and we're dealing with anything that's not CO2. That's the kidney's job to regulate, and that's how we're going to balance acids and bases. So a lot of chemistry going on with the renal system here. A few more things. Gluconeogenesis. Genesis in the beginning, glucose. So in the beginning, we're going to regulate new glucose. So gluconeogenesis during prolonged fasting. And we'll talk about that when we get into it. So if we get too low, we're going to talk to the kidneys, and we're going to tell them to start helping us to do some things with glucose. So more on that later. And then the hormones we've touched on. Renin is going to regulate the blood pressure. That's the whole thing that kicks off the chemistry that goes behind that reaction. And then something we talked about way back in the first chapter, in chapter 17, is erythropoietin, EPO. Remember, the kidneys are the ones that secrete that hormone when oxygen gets too low. One way we can bring up oxygen is make more red blood cells, and the hormone that says make more red blood cells is EPO, erythropoietin, and where that comes from is the kidneys. So the kidneys have a lot of jobs, and they help metabolize vitamin D to get it in the active form that we need. So, how long do you think you can survive when the kidneys fail?
Not long.
Not long at all. 30-ish minutes. If you have complete renal shutdown, because it does all those things. It filters, it excretes, it purifies, it regulates volumes, our water balances, our salt balances, acids and pH. So many things can go wrong if the kidneys aren't working. So we only have about 30 minutes. If we have complete renal failure, it's a crisis situation. All right. So the anatomy, we have 2 kidneys on either side. Kidneys are said to be retroperitoneal, retro in the back, and then in the cavity, the peritoneal cavity. So our kidneys sit back here. They're not anterior like all of our other organs. They're behind everything. So they're called retroperitoneal. They sit right back here at about T12 to L3. They're pretty small. They're about the size of a bar of soap. If you have a bar of soap in your hand, pretty small. It's about 5 ounces. And then how we get the fluid out of the kidneys is through the ureter. Fluid's going to drain down the ureters and bladder and out. Or we're going to reclaim 98% of it, and that's through our capillaries and our blood vessels, and then our lymphatic fluid as well. So we're going to reclaim the majority of stuff that goes in, but some of it's going to come out. So we have lots of ways to go in and out. Here's our picture. So this is our peritoneal cavity, your whole abdominal, lower abdominal cavity. And you can see where our kidneys sit to the back. If you look on the ribs, those 2 floating ribs, 11 and 12, are the ones that are protecting our kidneys posteriorly. The kidneys are protected by the ribs. And then they have 3 layers in there. So here's our, let's pull that up a little bit. So here's our kidneys. They're surrounded by fat. The fat helps protect them, but it also helps hold them in place as well. So it's kind of a stabilizer in there. They have a capsule that goes around it, so a perirenal capsule, a fibrous capsule, and we have fat. So we have 3 layers of support for our kidneys. The renal fascia, just like everything, has that tissue paper thin covering that goes like saran wrap that goes around it, just like all organs have. So fascia is that saran wrap that covers everything. The fat capsule cushions it, holds the kidneys in position. And then there's also a fibrous capsule that goes around it so that it keeps things out. It's a physical barrier. and it keeps infections from surrounding the cavity, spreading into the kidney. So it's just three, the fascia and the fibrous capsules are physical barriers, and then the fat is more like cushions it and holds it in position. So the kidneys have 3 layers of support in that aspect. Renal ptosis. Ptosis means droopy. So the fat is surrounding the kidneys and helps keep it in position and stabilizes it and protects it. And if we have rapid weight loss, like extreme weight loss over a short period of time, then the fat goes away. We see this like on Survivor, where you're fasting or something, or Biggest Loser, where you're losing huge amounts of weight. And when we lose too much fat, the fat holds the kidneys there, and they can kind of droop down a little bit. And when they droop down, then what happens is those ureters get a kink in them because they kind of sag down. The fat is holding them in place. They kind of sag down, and that can kink the ureters. So that can become a problem if you lose weight too rapidly. We call that renal ptosis. Kinks occur, and then the urine can't drain. It's going to back up into the kidneys, and we can get obstructions, and that's called hydrowater nephrosis. So renal is referring to kidneys, and nephr is referring to kidneys. So how I learned that was you have a nephew sitting on your knee, nephr, nephew, and kidney. So nephr and renal go together, they mean kidney. That's the terminology referring to kidneys. So hydronephrosis, a condition of water in the kidneys if we get a backup when those if the ureters can't. Okay, questions so far? Now it gets interesting. So let's blow this up. Now we're going to look inside the kidney. So the basic, yes.
I'm sorry.
No problem.
So when people have dialysis,
Uh-huh.
is that because you're trying to prevent renal failure? Or?
Right, so if we're in dialysis, one of 2 things is probably caused. So there's a crisis situation and some trauma has happened and your kidneys are shutting down. And you have to put them on dialysis, which is a machine. You bypass the kidneys and you go out to the machine and it filters and purifies and dumps it back in. So the kidneys can't do that. So it's a trauma crisis situation where something's gone wrong in surgery, or there's been some kind of trauma, or you're in an end-stage disease like diabetes. So 2 reasons why you're going to be in renal failure is some kind of crisis has happened. That's short-term, and you can often reverse that. If it's a long-term buildup to renal failure, like diabetes, then that's a reversible thing. And then that person starts going on dialysis because the kidneys aren't working, and then once you're on it, you're going to stay on it. So a crisis thing, hopefully you can turn it back around. If it's a long-term chronic thing, you're going to stay on dialysis. And we'll talk more about that at the end of renal disease versus renal failure. And it has to do with how functioning are your kidneys. All right, so here we are looking inside the kidney. So your basic kidneys, renal system, pretty easy. 2 kidneys, 2 ureters, a bladder, and out the urethra. Easy peasy, if only it were that easy. So now we're going to look inside the kidney, and here's where all the action happens, is in the kidney, we have this outer layer called the cortex, and then we have this inner layer called the medulla. Both renal cortex, renal medulla. So the cortex is this outer shell, and then the medulla is this inner area. Inside the renal medulla, we're going to have these little pyramids, and those are called calyx, or what the individual things are called pyramids. So we have 1, 2, 3, 4, 5, 6, 7. We have 6 to 8 renal pyramids. Those pyramids are going to drain into these little areas. Each pyramid is going to have a little drainage area, and that's called a calyx. So we have 6 to 8 minor calyx. The pyramids are going to drain into those little funnels, and those funnels are called a calyx. Each individual pyramid drains into a minor calyx. The minor calyx then are going to drain into 1, 2, 3 major calyxes. So the minors are attached to the pyramids, and then the majors are just these areas drain off of those. And then we get into this area called the renal pelvis. So we have an order of drainage. The blood's gonna come in, and then it's gonna get filtered from the cortex to the medulla. Once we get into the medulla, all the work is happening, and then we're draining down from the pyramids into this little area called the papilla of the pyramids. We go into the minor calyx, we go into the major, 2 or 3 major calyxes, we go into the renal pelvis, and then we're gonna go out the ureter, and down to the bladder. So all of this is the anatomy when we're looking inside. In between the pyramids, we have things called columns. So from the outside, renal cortex, this area is a renal medulla. These are our renal pyramids. We have renal columns in between the pyramids. The pyramids drain into each individual little thing, and those are our minor calyx. The minors are going to drain into these areas called the major calyx. The major calyx are going to drain into the renal pelvis. And then we're going to go down here. So that's the inside anatomy. When we cut it in half, that's what we're looking at inside the kidneys. Questions over that?
So the renal column are the.
Just these spaces between the pyramids. The pyramids are kind of a dark reddish color, and then the columns are the spaces in between each pyramid.
And what is that hand part again?
The what?
The last thing that you said.
Renal pelvis,
The one
and then
here.
ureter.
Okay.
So the pyramid is renal medulla?
The pyramids live in the renal medulla, yes. So the pyramid is entirely located in the medulla. The outer part is the cortex, the inner part is the medulla. So the pyramids are contained inside the renal medulla. Yes.
What's the yellow things on the end of the column?
Fat.
That's that.
All right, so we're gonna go, when we go to lab, we're gonna look at, gosh, we have so many models in there. We're gonna look at 3 or 4 different models, and that's what we're gonna look at. So on the lab test, they want you to be able to identify each piece and part inside the kidney. So we're gonna look at kidneys, we're gonna look at ureters, we're gonna look at bladder, we're gonna look at urethra. So that's the large model. Then we have a cross section, and then we're gonna look at the kidney inside, and I want you to be able to identify all of these individual parts here. Sometimes the question is, where did it just come from, or where is it going to? We know how they love that question. So the order of flow goes renal cortex, renal medulla, inside the pyramids. The pyramids are drained by this papilla. The papillas drain into the minor calyx. Each pyramid has a minor calyx. The minor calyx is drained into just these 3 areas called the major calyx, and those drain into the renal pelvis. Then they go into the ureter, the bladder, and out the urethra. So that's lab stuff. As far as identification, they can tag any of this and then just know the anatomy of how to identify that. Or they're going to say, where did it just come from, or where is it going to next? So it just starts on the top, works our way down to the ureter.
So that minor goes back up to major.
The minor comes down to major. Each individual pyramid is a minor. So the flow is going to go from out to in. So those minor, all of these are minors, and those are draining into the major areas.
Okay.
And then this area is called the renal pelvis.
We're gonna have an actual organ,
No, just models.
Yes. If you have renal problems, is the whole kidney or both kidneys affected, or just one or two?
It depends. It can be just one. It can be both. It just depends on what's going on.
And that's, the problem would be like inside here? That is
Right, inside here. Yeah, so we're peeling off layers of the onion. We've seen the basic anatomy. Now we've seen the inside, and we're gonna go even deeper and see more stuff in here. Yeah, so the problem can be anywhere in there. If we get kidney stones, what happens is it gets calcifications in there, and then the stones collect here in the renal pelvis, but then they have to go down the ureters. And the ureters are really flat, They're not open and hard things, they're just like little thin tubes. And then that kidney stone has to go down through there, and the stone is crystallized, and it has jaggedy points on it, and it has to go down those flat little thin tubes. So as it moves, it's just like razor blades just ripping down through there. Does anybody ever have kidney stones?
Yeah, I had to undergo a lithotripsy,
Yeah.
and I was just wondering, like, so when they do that, how does that work exactly?
So lithotripsy is ultrasound, and when you have the stones in there, they'll do a dye study. Did you do a dye test?
I can't remember, it was so long ago.
Sometimes they'll do a dye test where you drink something, and then they'll do a video fluoroscopy, it's a fluorescent dye. They'll do a video fluoroscopy, and then you'll see where is it draining. And when it hits that block, then it doesn't drain, the other side keeps going, but it doesn't drain. So if the stones are too big to pass on their own, then they'll come in and they'll do ultrasound, which is lithotripsy, and they'll just radiate it, or they'll just ultrasonically blast them. So it blasts them, and it breaks it up into little fragments, and then they're easier to pass.
What if it's,
So it feels like beep, 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 kind of thing.
I've seen like, you know, crazy in museums and stuff, like kidney stones that were that
Yeah,
big.
huge. And if lithotripsy doesn't work, then they'll surgically go in and cut them out. So hopefully you can, A, pass them on your own, B, lithotripsy, or finally C, they do surgery to take them out.
So, yeah, I went in to see a uro gynecologist, I believe the only one in the city, Deborah Miller.
Okay.
Did an ultrasound, because I'm having some bladder issues. My doctor's office called and told me that they found a tiny, real tiny
Stone.
stone in my kidney. So I'm worried. I'm like, okay, so it can get larger, or,
It probably won't. I mean, if it's tiny, you'll probably pass it and not know about it.
okay,
But it can be what causes them, you just happen to get them. It can be familial, like genetic. If you have a family history, you might be more prone to it. It can be a diet thing. It's just something that happens. I had them when I was probably maybe 28 one time, totally out of the blue, no apparent reason, nobody else has them. It was the worst pain. It feels exactly like labor pain that won't go away. So labor pains, at least you get a break, right? Kidney stones feel exactly like labor pains that are nonstop. So I'm just going about my business, and you get referred pain down here to the groin or right here on the back. And I was like, gosh, my back really hurts. My back hurts so bad. I was like, what is going on? And so walking down the hall in my office, 4 to 6 is your busy time, and I'm like, oh man, my back hurts. Start sweating. It's like, what is going on? All of a sudden, drop to my knees right there in the hallway because they start moving. It's excruciating pain. I was there with another doctor. And he's like, well, what are you doing? I was like, ah. Crawled into another room. Literally crawled into another room and laid there in a fetal position because it is just unrelenting pain and just sweating profusely. He's like, you gonna be all right? He's like, oh, no, he goes, because we got a lot of patients. I'm like, empathy is not your strong suit. And then it passed, and about 20 minutes later, I'm like, oh my gosh, that was horrible. What was that? And then I was fine. Never happened again. Just a random kind of thing. And then it gets to your bladder. And so then the bladder's nice and big, so it just sits there, and then you get out the urethra. And in the women, the urethra is only 1.5 inches, and so you don't really notice it too much. In the male, the urethra is 6 inches long, so they've got a whole lot more excruciation to go through. For a woman, you gotta be like, ah, and then you're done. For the guys, it's like going down the ureters. So men have a lot worse in that situation over us.
I had a boyfriend that happened to, and it was horrible,
It-
horrifying.
It's
We didn't know
horrible.
what was going on, and he did that same thing, he dropped down on the ground and
Yeah.
just screamed, and it was,
Yeah, and you just can't get away from the pain, there's like no escape from it. So, yeah, and then they'll move and then they'll stop, and then you're good. And then they'll move and then they'll stop, so until it comes out. And luckily mine must have been fairly small, but it is not a fun thing.
What causes those kidney stones?
Just different things, diet, hereditary, excess calcium, just depends on lots of different things can lead to it. And hopefully I never get it again. I have
For
once.
real.
Hopefully it never comes back again. But every now and then you'll get a back twingy pain, you're like, ooh, I hope it's not that. Flash back to that.
My sister gets them all.
Oh, yeah. And people who get them tend to get them for
Yeah. She drinks a lot of soda though, so.
Yeah, that's not good.
That-
Cut that out.
Yeah.
Because you get into the whole calcium phosphorus imbalance there. Okay, so here it is in writing, our three main parts. The cortex, the outer part, is very granular looking. The medulla is the inner part, and the pyramids are contained inside the medulla, the 8 pyramid-shaped lobes. We have stripes in there because we have something called tubules. We have tubes going down, it makes it very striking. And in between the pyramids, we have the columns. And then we drain into the renal pelvis, which is the minor calyx, major calyx, renal pelvis. The calyx, we have 2 to 3 majors and several minors. However many pyramids we have, each pyramid has a minor calyx attached to it, and those are going to drain into the major. And then the cup-shaped areas at the end are the papilla, the apex of the pyramid then drains into the papilla, which goes into the minor calyx, which goes into the major calyx, which goes into the renal pelvis. So there's our order. The calyx collect urine. The urine comes from the papilla, and it drains into the minor, the major, the renal pelvis. Yes. And then down into the bladder and out the urethra.
So does urine ever get trapped in the kidney, or does it always flow into the water?
It can, that was the word we saw earlier, hydronephrosis. So if for some reason it's backing up, it can get trapped in there, and that's hydronephrosis. Or if you get a kink in it or a stone, so yeah, it can back. UTIs can cause inflammation and irritation. Urinary tract infections can cause irritation and no fluid can't drain, and then it's just gonna back up. How do we move things through? That's called peristalsis. So remember, we're in smooth muscle now, and the ureters are smooth muscles. They're hollow organs draining something, and what they're draining is urine. So how we move is called peristalsis. The walls of the calyx, the renal pelvis, the ureter, and the urethra are all lined with smooth muscle. The bladder as well, lined with smooth muscle, and it has a rhythmic contracting that happens, and that's called peristalsis. It contracts and then it relaxes. It contracts and then it relaxes. So that's how the muscles are contracting. So instead of skeletal muscle contracting and relaxing voluntarily, smooth muscles are contracting and moving via peristalsis. So things that can go wrong is infection, pyelitis, infection of the renal pelvis and the calyx, so pyelo of the pelvis, inflammation in the pelvis. So for whatever reason, it's backing up, and then we can get inflammation in this area where the calyx and the renal pelvis is. That's called pyelitis. Or if it involves the entire kidney, then we add the word nepher, because nepher means kidney, pyelonephritis. So if it's just of the renal pelvis and the calyx, the draining areas, that's called pyelitis. If it's the entire kidney, then we add the neph part in there, infection or inflammation of the entire kidney. It's more common in females than in males because our urethra is very short, it's 1.5 inches long. And it's not very far from the anal opening, so this is why we always want to wipe from front to back. Because if you wipe the other way, the bacteria, fecal bacteria can come forward and go in that short little urethra and into the bladder and up the ureter. So it can cause infection because it's a dark, moist environment, very easy for infection. So this is why girls, women get UTIs much more frequently than men do, just simply because of the anatomy. And when you're teaching little girls, when you're potty training, you're always teaching front to back, because you know you're just happy if they can go to the bathroom on the potty, and then you got to get into hygiene aspects of it. So always teaching front to back. And if it backs up and it goes untreated, it can cause serious problem because then you're really pressurizing the kidneys and causing all kinds of extra work on them. So you got to get on an antibiotic, or depending on what's going on in there, get on some kind of medication and get that treated and cleared up before it gets out. And usually it's pretty uncomfortable, so people are pretty quick to go to the doctor when they have some kind of urinary tract infection or some kind of renal thing going on. So it's not one of those things like, oh, it'll go away on my stomach. You're like, oh, wow, I gotta go to the doctor. I'm really uncomfortable. Okay, a couple more slides here. The blood supply. So the whole idea is function is filtration. So we gotta get the stuff in, we gotta get the fluid in. And it's a very, very vascular organ, so it has a rich blood supply. We're filtering and cleansing the blood. The renal arteries deliver 1/4 of the total cardiac output to the kidneys every minute. So of those 5 liters that the heart is pumping out, 1/4 of that goes straight to the kidneys every minute, every time we're beating, every time. They branch in lots and lots of arteries, and then the veins are going to do the opposite. So here's our picture of it. Let's blow this up a little bit. And it looks like a lot of stuff, but just pay attention to the words, and they describe where they're going. So first we're going to come in off of the aorta. Here's our aorta, here's our flow in the red arteries. So we branch off the aorta, we go into the renal artery. Then we're going to have segments, so we have segmental arteries. So it goes aorta, renal artery, branching off into segments. Then we're going to go in between the pyramids, so interlobular, in between the lobes. Then we're going to arch over the top, so that's called the arcuate artery. And then we're going to radiate out into the cortex, so that's the cortical radiate artery. And then teeny tiny little arteries are going to branch off of that, and those are our afferent arterioles. And then they're going to go into something called the glomerulus. So this is our blood flow coming in. We're branching. And that'll be another lab question is what artery is this, or where is it going to, or where is it coming from next. So lots and lots of branching, and this is the flow of it. Aorta, renal artery, segments branching off of that, so segmental arteries, going in between the lobes, interlobular, arching across, arcuate, and then radiating out into the cortex, cortical radiate arteries. And then off of those, each cortical radiate is going to have a little branch, and that's our afferent arteriole. Then they're going to go into something called the glomerulus. Then we're going to drain it, and it's the same thing leaving. So we come in the afferent, we exit the efferent, same as everywhere in our body. And then we're going to go out something called the peritubular capillaries or the vasa recta. That's how 98% gets returned back to the body. So we'll look at a picture of that. And then we just reverse the order. Cortical radiate, arcuate, interlobular, renal, and inferior tubular. So we're coming back out. We're going to go out in this area. We're going to go out the capillaries. We're going to return 98%. And then we're going to leave the cortical radiate. We're going to